you again. So we have already one raised hand. Okay, there are many. Uh,
It's an LTE system, so it's basically the same system that is now on one of the rovers that's or where Nokia has provided the payload. So it's LTE, it's like 4G basically. Uh, I have to say I don't know the frequency right now, but I'm sure it will be made compatible with the assets that are around the moon.
Next question, please.
For the gravitational wave antenna, I was wondering, with the placements of every basically node 1 kilometer away, what's the current plan for the deploying of them actually on the surface and the distancing, and then also ensuring, I guess, I saw the leveling system, but even like securing them on the ground. Is there a plan defined for that yet and a procedure?
So for the moment, we don't believe that the mounting is a major issue, but we will make deployments in lunar analogs to understand that issue really more precisely, as was done for Mars Insight as well. So these issues are, of course, known. But generally, I mean, of course, it's a complicated deployment. So it has to be done by, I assume, a rover. And so bringing the stations away from the lander, at least 3 of them, spread them out is, yeah, well, we propose it in that way, that you have a rover going and then leaving the stations. But these are parts of the mission that we haven't really looked into detail yet. So, but in any case, about the deployment itself of each station, we will look into this at least from simulation side and from lunar analog studies.
Okay, thank you very much.
Hello. Hello. For the Lunina payload, I have a question. So, what distance can you reach on the lunar surface with the beacon and the communication service?
Well, that detailed design has not been done yet, but it depends on what's the elevation. The higher you get, if you put the package on the high on the crater, then you get more distance, and then. But I think it should be at least kilometers on the surface. So, for example, for the lunar bases or other like lunar rovers that are working on the moon, you could like drop them just like you would drop like these relays on Earth, but drop them with a sufficient distance, and then they would cover some area that you need. And of course, the closer they are to each other, the more accurate it is, and the higher you have this, because they can also work together.
Susan Stewart from the U.S. Naval Observatory. This is a question for probably the last 2 talks. It would be good, or maybe a comment, it would be good for these projects to be speaking with the people that are developing the time standards and also the surface frame accuracies to know what your requirements are, because we're coming together now and we're trying to decide what we're going to be, how we're planning these things. So we've been trying to reach people and the users and the levels that we need to be at. Usually when we ask what are the requirements, they say, well, how good can you get it? So it's good to know and see these.
Thank you for this comment. I just like to add that if you think about Lunina, so the platform itself, which is based on LINS, so it's like pretty much preliminary designed already. And this LTE system, well, Nokia's LTE systems, we know that they exist, and the work to actually bring those two together is only starting. So this is an idea that was proposed, and we do have a collaboration with Nokia on this. But the practical work of implementing this Lunina is only starting now.
Okay, so do we have any other questions? All right, let's thank the speakers again. Thank you very much.